Good morning to one and all. I welcome you all for the module Unconventional Machining Process, Class 2. I am Dr. Tirupataiah Kasani, Assistant Professor in the Department of Mechanical Engineering at School of Engineering and Technology, Adamas University, Kolkata, India. Sorry. Yesterday, we have seen in the last class, we have seen that is abrasive jet machining and ultrasonic machining. These are the two unconventional machining processes, working principle, material removal mechanism, applications, followed by advantages and disadvantages of those two processes. And now the next unconventional machining process, that is electron discharge machining process, shortcut we can call it as EDM process. Okay, and in this the contents are as follows. Contents will be introduction, working principle, material removal mechanism, applications, and advantages and disadvantages. Electric discharge machining, that is electric discharge machining, that is EDM. Here it is the schematic of electric discharge machining setup as shown here. Here it is the dielectric storage tank. Dielectric is the medium which will be used for the removal of the material from the workpiece. Here, this is the workpiece and this is the tool feed. As earlier in the two processes, that is AJM and USM, we already discussed that the tool shape will be same as the cavity that you want to create over the top surface of the workpiece. Means the tool shape and the material removal shape on the workpiece will be same. Here also the shape will be is rectangle, means the cavity that is formed over the workpiece is also a rectangle. Okay, this is the tool feed. Similar to the USM, the feed motion is up and down, but this is not the vibration. This is a continuous linear feed motion, either downwards or upwards, depending upon the location of the workpiece in the in this tank, dielectric fluid medium. Okay, here this is the dielectric storage tank. What is the dielectric storage tank? Means what is a dielectric medium? Dielectric medium is the one which doesn't allow the electric charge through it, electric current to pass through it. Okay, which does not allow the passage of the current through it. We can call it as dielectric medium. We are using that medium. This is the tank. This is the EDM tank. Okay, this is the storage tank, dielectric tank. This is the EDM tank, where this will be filled with the dielectric medium. Generally, deionized water or the kerosene are used as dielectric medium. Most of the cases, dielectric medium is deionized water. Okay, in most of the cases. Here it is the dielectric circulation pump, means the dielectric is fed to this chamber or the machining zone tank using this dielectric circulation pump using the filter. This filter will be used to extract the chips, to extract the removed chips from the workpiece material, means these filters. Okay, after that, at certain amount of pressure, this water or this dielectric medium is supplied to the tank. This is the nozzle flushing. Okay, means with a certain amount of pressure and velocity, the dielectric medium is fed to this machining zone as well as in this tank. Okay, see here, the tip is focused to the machining zone only, and this is completely immersed in the dielectric medium. Means the fixture, workpiece, and the tool, three are immersed in the dielectric medium only, and this nozzle is positioning towards the machining zone of the EDM. Okay, machining zone of the EDM process. Here, this is the servo controller. Okay, this is the DC plus generator, means the power supply from here to the servo motor control. Servo motor control, which will be helpful to feed this tool in a precise manner, either upward or downward. Means the control of this tool feed is completely controlled by this servo control. Okay, of course, this is the power supply. As the power supply, this is one connection plus, and this is the tool that is connection negative, plus and negative. These are the two terminals to complete the circuit. Of course, see here, this is the table. Again, this is the fixture table. Here also the tool, either tool will be moving or workpiece will be moving, means depending upon the construction of the equipment. Okay, in this case, generally the tool is moving. Okay, nowadays the tool is moving in few machines. The workpiece also, the work table also is moving. This is the one. Means what is happening, what is the reason for removing the material using this tool with the workpiece. Okay, as we have seen, there is no direct contact of the tool and the workpiece in AJM as well as USM. Similarly, here also in EDM, there is no direct contact of the workpiece and the tool. Here, there is a gap between these two. How the material is removed from the workpiece? When the power supply is given to it, a high potential difference will be generated between the workpiece and the tool that results in the formation of the spark, high energy spark, and that spark will remove the small amount of material from the workpiece. Means the melting and evaporation followed by the cavitation. The mechanism of material removal in EDM process is melting, evaporation followed by the cavitation. What are these three? Melting means due to the spark, high energy spark, the material is melting. After that, it gets evaporated. Okay, and after that, the cavitation will occur. Okay, the bubble formation and all will occur. That is further promoting the removal of the material from the machining zone. Okay, here this is the workpiece and this is the tool. All this process will be happening inside the dielectric fluid medium, not in the open atmosphere. See here, due to this non-conductivity nature of the mm, dielectric medium, means it is not allowing the current to pass through it. That is the reason why initially the potential difference is developed between the workpiece and the tool. And how the spark is generated, we will look into it. Schematic representation of the plasma formation. See here, this is the tool holder and this is the tool electrode, that is negative, and this is the workpiece. This is the workpiece and this is the tool and this is the tool holder. See here, this is the tool wear, this is the small portion tool wear, and this is the molten metal. See here, this region will be the molten metal. Okay, this is the crater. This is the crater. See here, recast layer. What is this recast layer? After melting, as I told, after melting due to the spark at higher temperature and high energies, the whatever the molten metal that is generated due to the spark or the top surface of the workpiece is not completely removed by the flow of this dielectric medium. A small amount of molten metal is stick to the workpiece, that we can call it as recast layer. Means after melting it is again solidified and it is stick to the workpiece top surface, that is recast layer. This is the workpiece is positive and tool is negative. This is the crater and this is the vapor. See here, these are the vapors. This is the plasma channel. Yes, you know, plasma means the highly energized charged particles, that is plus and negative, both anions and cations. This is positive ions and negative ions. Here it is the dielectric flow. See how this is the dielectric flow. This is the solidified metal. See these two are the solidified metal. Means what is happening, what these are all different parts. Means plasma formation representation, the various components. This is the molten metal and this is the solidified metal, dielectric fluid and tool wear. Now we will see step by step how all these will be originating, or how all these are forming between the tool and the electrode. When the power supply starts, there is a potential difference is started between these two electrodes, means that is positive, and electrode, that is tool and the workpiece. Workpiece is positive, means more number of positive ions are accumulated here, more amount of negative ions are accumulated here. Okay, in between the dielectric medium. At certain point of time, as at certain point of time, the flow of the electrons from the electrode to the workpiece will start. Similarly, the positive ions movement from the workpiece to the tool will start, means the flow of the positive and negative ions, that is called plasma channel. Okay, this is the plasma channel. This is plus and negative. This is the black color one will be the positive, and the hollow circular will be the negative. Negative ions is moving downwards and positive ions is moving upward. That is highly energized medium, that is plasma is generated. Okay, means due to this plasma, a spark will be generated, okay, between these two. Okay, due to that spark, the amount of material from the workpiece is melted, and a small portion of the metal from the holder or the tool also melted. See here, due to this the tool wear occurs, means this is melted, I can say 5 to 10%, and this is 80 to 90%, means most of the energy is used by the workpiece, means whatever the spark energy, means more amount of the material is melted from the workpiece. Of course, there is a dielectric medium flow, means whatever the metal that is melted will be taken away by the dielectric medium. These are the solidified metal particles which are removed from the workpiece only. Okay, this is the dielectric flow due to the nozzle here. Due to the nozzle, the flow is always there. Okay, what about this vapor? Here, due to the spark, the metal is melting. Okay, after the melting, it gets evaporated. Okay, due to that, the bubbles are forming, and again, due to low pressure of these bubbles, this again is coming in contact with the workpiece, and it further promotes the removal of the material. Okay, vapor bubbles, water is coming in contact with the workpiece, those will collapse and will further promotes in removing the material, means that is the reason why after the spark generation, the melting, evaporation followed by the cavitation due to the bubble formations in that region. Okay. Sorry. See here the schematic of spark generation in EDM. This is the molten work metal. This is the workpiece, that is anode, and this is the cathode tool, that is plus and negative. This is the molten metal. See here, small amount of molten metal. Here it is the high amount of molten metal. This is the spark discharge column or ionized column. That is the plasma. Within the plasma, this is the spark generated. This is the dielectric fluid molecules. These are this column is surrounded by the dielectric fluid molecules. Of course, this is the DC source, the power supply. Okay, this is how the spark is generated, not only at one region, in number of regions. Okay, here just for better understanding purpose, only one spark is represented. Okay, number of sparks are generated instantaneously between the tool and the workpiece, which results in the melting, evaporation, followed by the cavitation. That is the material removal mechanism. Okay. Electric discharge machining, EDM is typically applicable for materials that are electrically conductive. As we have seen the plus and negative. Plus will be the workpiece and negative will be the tool. That is, electrical conductivity is must for the workpiece and the tool. Although methods for machining insulating ceramics with EDM have been proposed. Okay, EDM can cut intricate contours or cavities in hardened steel without the need for heat treatment to soften and reharden them. Okay, means this EDM process is used to cut the intricate contour or cavities in hardened steel. Hardened steel is more harder. Okay, means to harden that steel. Okay, this process will be used. And here it is the working principle. Electric discharge machining is a process of material removal based on the principle of material removal by an interrupted electric spark discharge between the electrode tool and the workpiece. See here, EDM is a process of material removal based on the principle of material removal by an interrupted electric spark discharge due to the generation of the plasma between the between the electrode tool and the workpiece. In EDM, a potential difference is applied between the tool and the workpiece. This is the process. Okay, a gap is maintained between the tool and the workpiece. We have already seen that gap that is filled with the dielectric medium. Here, what are the essentials for this process to use? Both the tool and workpiece are to be conductors. If these are not conductors, then we are not going to use this process EDM. Okay, conductivity is must for the tool and the electrode. Tool and the workpiece. The tool and workpiece are immersed in a dielectric medium. We have already seen anode will be the workpiece, cathode will be the tool. Generally, kerosene or deionized water, as we have already discussed, is used as a dielectric medium. Most of the cases, the deionized water. Mechanism of material removal is melting and evaporation followed by cavitation. And the typical material removal rate in this is 0.5 to 21 mmq per minute. This is the typical removal rate, that is MRR. As the dielectric, as the electric field is established between the tool and the workpiece, the free electrons on the tool are subjected to electrostatic forces. This is well known, the basic point. If the bonding energy of electrons is less, electrons would be emitted from the tool. As I have seen, after the power supply, initially from the tool, the most of the electrons, the negatively charged ions, are accumulated in the tool side, and positive ions are accumulated in the workpiece side. Okay, the between space, the in between space will be occupied by the dielectric medium. Okay, such emission of electrons is called cold emission. Okay, due to the cold emission, there is no spark generation. Why? Because there is no movement of the ions from one end to the other, from positive to the negative or negative to the positive. Okay, the electrons are accelerated towards the job through the dielectric medium. Okay, as the electrons gain velocity and energy and start moving towards the job, there would be collision between the electrons and the dielectric molecules. Yes, when positive ions are moving towards the negative ions, negative ions moving to the positive ions, there is a dielectric medium through which they must and should go through. Okay, during this travel, this positive ions and the dielectric medium particles will collide. Similarly, the positive and dielectric medium particles will collide, and the positive and negative ions will collide. Means the molecular collision in between region is must and it is unavoidable. Such collision may result in the ionization of the dielectric molecules. Ionization depends on the ionization energy of the dielectric molecule and the energy of the electron. Okay, means this is a dielectric molecule. As the electrons get accelerated, more positive ions and electrons would get generated due to collisions. Yeah, due to these collisions phenomena, number of positive ions and the electrons would get generated. More positive and negative ions are induced further due to this collision. This cyclic process would increase the concentration of electrons and ions in the dielectric medium between the tool and the workpiece at the spark gap. At the spark gap, in the sense, the gap between the tool and the workpiece. The cyclic process means number of collisions, not only with number of, means lakhs of molecules or the ions will collide and will generate number of positive and electrons. Further, in the same gap, the spark is generated. Okay, the concentration would be so high that the matter existing in the channel could be characterized as plasma. Okay, whatever the gap that is there in between tool and the workpiece, we can call it as plasma when there is a high positive and negative ions are accumulated, highly energized plasma. The electric resistance of such a plasma channel would be very low. See here, the electric resistance of such a plasma channel would be very low. That is the reason why, which further results in the formation or the generation of the spark in the plasma region. Thus, all of a sudden, a large number of electrons will move from tool to the workpiece and ions from workpiece to tool. This is called avalanche motion of electrons, means the start of positive ions to the negative or negative ions to the positive is called avalanche motion of electrons. Such movement of electrons and ions here in the sense positive, electrons in the sense negatives, okay, negatively charged particles, can be visually seen as a spark. The spark is nothing but the combination of ions, positive ions and negative ions. Thus, the electrical energy is dissipated as thermal energy of the spark. Okay, as of now, these are the positive ions, negative ions, that is electrical energy. When it is converted into spark in the plasma region, that we can call it as thermal energy of the spark. The high speed electrons then impinge on the job and ions on the tool. Okay, the high speed electrons then impinge on the job, that is workpiece, and ions on the tool. Okay, means positive ions in the tool side. That is the reason why in both the regions the spark is in contact and some amount of material will be melted. Of course, from the workpiece side, it is more amount of metal is melted, and from the tool side, it is less amount of metal is melted. The kinetic energy of the electrons and ions on impact with the surface of the workpiece and tool respectively would be converted into thermal energy or heat flux. Okay, that is what we discussed. Uh, Such intense localized heat flux leads to extreme instantaneous confined rise. Extreme instantaneous confined rise in temperature, which would be in excess of 10,000 degrees centigrade. See here how high the temperature is. Generally the room temperature we can it will be in the range of 30 to 35 degrees centigrade. But here the temperature is 10,000 degrees centigrade. Imagine how high the temperature is. Such localized extreme rise in temperature leads to material removal. Okay, at these high temperatures, the material gets removed from the workpiece as well as the small amount from the tool. Material removal occurs due to instant vaporization of the material as well as due to melting. Okay, due to the instant vaporization as well as spark melting. Okay, due to the spark, the molten metal gets melted. The molten metal is not removed completely, but only partially. Okay, that is the reason why the recast layer is forming over the workpiece. Okay, upon withdrawal of potential difference, okay, the plasma channel collapse, means whenever the power supply stops, there is no plasma region. Again, that region will be occupied by the dielectric medium as usual, regular. This ultimate this ultimately creates a compression shock waves on both electrode surfaces. Okay, whenever there is a plasma channel collapse, it will create some amount of shock waves on both the electrodes, that is tool as well as the workpiece, particularly at high spots on the workpiece. Why? Because here more amount of heat is generated due to the impingement of electrons, that is negatively charged particles which are coming from the tool. Okay, more amount of heat is generated in the workpiece side. Okay, that is the reason why, particularly at high spots on the workpiece surface which are close to the tool. Okay, this evacuates molten metal and forms a crater around the site of the spark. That is the reason for the formation of the crater around the spark region. We have already seen this, how the crater is in the earlier video. See here, wire electric discharge machining. Till now, we are talking only about the tool shape and the cavity that is created on the top surface of the workpiece, that is after the material removal, both the shapes will be same. Means the same tool shape is replicated over the top surface of the workpiece, and the whole thing will be immersed in a dielectric medium. However, here, see here, wire electric discharge machining. What is this wire electric discharge machining? We know electric discharge machining. There is a tool, workpiece, and both will be kept in a dielectric medium. Both will be immersed in a dielectric medium, and the process is happening, and the material is removed. We have already seen what is this wire electric discharge machining. Why electric discharge machining? The schematic is looking like this. See here, this is the pump and this is the filter. See here, this is the tank. Then this is the machine bed or the machine table. Okay, using fixture, we are going to mount a workpiece here. Okay, a workpiece here. Here, this is the deionized water. This blue color will be the deionized water. The same pump and the filter earlier to that. Okay, continuously the dielectric medium is supplied to the machining zone. This is the machining zone. See here, wire guide, and this is the wire. This is wire pulley. This is wire pulley and this is wire pulley. Means this is releasing the wire and this is winding up the wire. But here these are the wire guides. These two are the wire guide rollers. See here, after releasing the wire by this wire pulley, okay, it passes through this like this. Okay, and it will wind up here. Okay, this is the continuous motion. This is releasing, guiding, cutting, guiding, and winding, rewinding again. Okay, this is the flow of the wire motion, and this is the chamber. If you observe the machining zone in an enlarged manner, that is here, this is the spark gap. See here, this is the wire diameter, the top view. If you cut the wire like this, and if you see from the top side, it is looking like this. This is the gap between the workpiece and the wire. This is the gap in which the spark and the plasma, whatever the phenomena that we discussed already, all the process will be happening in this region only, in this spark gap. This is the slot or the curve that is cut. Okay, in the workpiece. See what happens here. What is the difference between this EDM and viridium? What is the basic difference? There the tool is single shape. Okay, here the tool is wire that is continuously moving. Of course, these wires are coated with something. Okay, nickel. Okay, copper. Number of materials are used for coating this wire to improve the life and to improve the efficiency of cutting. Okay, that's a different story. Here the tool will be the tool is in the form of wire, and that is releasing here and winding here. A continuously moving wire is used as tool here in this wire EDM process. Okay, however, there is a continuous supply of this, what I can say, dielectric medium, and this is also immersed here. Okay, here the typical diameter of this wire is 0.25 mm. Okay, 0.25 mm. That is the reason why you can just imagine how small the gap here. In that small gap, high energy spark is generated and it causes melting the molten metal and material gets removed from that region. Okay, we have already seen 10,000 degrees is the temperature. Okay, see what is the use of this wire. With this wire, we can cut different types of profiles that we require. See here in this figure, see here, this is the movement of the workpiece or the wire. Okay, this is the shape. This is the slot that is cut by this wire. Means for the cutting process, the same process will be for the cutting purpose. The same process means the plasma generation, the plasma generation, spark generation, high heat, that is 10,000 degrees centigrade, melting, evaporation, followed by the cavitation. The same phenomena will be happen throughout this slot during the cutting process. This is the traveling wire. This is the workpiece motions. Okay, these are the wire motions. See here, unwinding, travel, cutting, winding. Iridium is used mainly for through-hole machining process. This is very, very important. See here, this is wire, okay, uncut wire. This is a continuous. That is the reason why mainly for through-hole machining process. This machining process will be used. See here, this is the supply reel, that is the wire, and this is the sparking action. See here, this is the wire, this is the workpiece, and this is the sparking region. This is black color. Of course, there is a continuous dielectric fluid from here to here. Okay, in this direction, in this direction. Okay, dielectric fluid and the machine swerve. See here, this is the workpiece and this is the electrode path. This is the electrode. Electrode is nothing but here it is wire only. Okay, the wire movement is like this. Of course, the control will be by the servo motor again. Okay, precise controller. Precise control of the electrode to cut the profile that is required for our application purpose. Okay, see here, what are the EDM applications? Drilling of micro holes, thread cutting, helical profile milling, rotary forming, and curved hole drilling. These are the main applications of this EDM. Delicate workpieces like copper parts can be produced by EDM, electric discharge machining. You have already seen the thickness of the wire is 0.25 mm only. And the other applications are deep, small dia hole using tungsten wire as a tool. See here, the tungsten wire as a tool. Narrow slots, cooling holes in super alloy turbine blades. See here, cooling holes in super alloy turbine blades. To improve the life of the turbine blades, there are cooling channels. Those will be cut using this iridium or the idiom and various intricate shapes. Since there are no mechanical stresses present, no physical contact between the tool and the workpiece, there is a gap, and in that gap, the spark is generated. Okay, and fragile and slender components can be machined without distortion. Hard and corrosion resistant surfaces essentially needed for die making can be developed. See here, EDM drilling, EDM sawing means the same principle will be used for the making holes, that is drilling, for cutting, sawing, okay, machining of spears, machining of dies and the molds. EDM advantages: complex shapes that would otherwise be difficult to produce with conventional cutting tools. Okay, and extremely hard material to very close tolerances. Extremely hard materials we can cut to the precisely we can cut the extremely hard material. Very small workpieces where conventional cutting tools may damage the part from excess cutting tool pressure. Okay, there is no direct contact between the tool and the workpiece. Well, now, therefore, delicate sections and weak materials can be machined without any distortions. And the distortion is a common phenomena in welding process. All of you know, due to the thermal energy. Okay, there is thermal distortion. Here also, at higher temperatures, thermal energy is present. Due to that, it may distort. Okay, but here there is no contact, means due to the direct force, means due to the direct contact, there is no such distortion. Only the distortion is possible with the help of this thermal energy only. A good surface finish can be obtained. Okay, and see here, these are the disadvantages. Slow rate of material removal and specific power consumption is high. What is the specific power consumption? Means the amount of energy required for removing a unit of metal from the material, that is workpiece material from the job. is very high in this process compared to the other conventional machining, other unconventional machining processes. See here, overcut is formed. Overcut. What is this overcut? Means whenever I am using this wire, okay, due to this wire profile, there is an extra amount of material removal in some portions due to their shape, that is overcut. And you have already seen in abrasive jet machining, as the jet is emerging from the tip of the nozzle, it is diverging. Okay, means that is the responsible for the outside cut or the overcut. That will be controlled using standoff distance or NTD distance. But here, this is the overcut is formed due to the, see here, this overcut is formed due to the intricate shapes. See here, excessive tool wear occurs during machining. It is common. And electrically non-conductive materials can be machined only with a specific setup of the process. See here, we have already discussed that conductivity is mandatory for the workpiece and the tool, but here I am saying electrically non-conductive materials can be machined only with a specific setup of the process. Means applying the conductive nature coating to the workpiece and loading it and start cutting. That is one possibility of cutting the non-conductive material that requires a special setup. Okay, that's it. We will meet in the next class with another unconventional machining process. Thank you.